Good afternoon, everybody. I'm here to present our work on the Shoe Attribute Challenge. I'm Ankit Sharma. I'm currently doing research at the University of Central Florida under Dr. Hassan Fadoush. My teammate Gonzalo is pursuing his PhD at the same university under Dr. Mubarak Shah. Let me start with a story. We have Amy here. She would like to buy a pair of sandals online. She logs into the popular websites such as Macy, JCPenney, or any other, and she goes to a shoe section, then the sandal section, and she starts browsing through images. And then she finds a pair of black sandals she likes, and she says to herself, I like this pair of sandals, but I wish they had lower heels. So she decides, let's look around a bit more. Then she finds another pair of black sandals which are flat, and she says, I like this pair of sandals as well, but I wish they were less open. Okay. Now she wonders how can she go and refine her search. Then imagine she was at a retail shop. She could have asked the shopkeeper, hey, I like this pair of sandals, but could you get me something a bit more different, which like something very similar, but less open? He would immediately realize what she's looking for, and he would go back to the store and get something very similar, visually similar what she was looking for. Now, this is the exact type of problem that we are trying to solve here. In the Shoe Attribute Challenge, what you're given is, given an image which considers two pairs of shoes, shoes A and shoes B, you're asked to find which of the shoe has more of an attribute, of the given attribute. Attribute, you could say they are mid-level representation of an image, semantic cues, which gives you a brief description of an object. And in our case, we're dealing with 4 attributes. First is open, second, pointy, third, comfortable, and fourth, sporty. What we do is, first, given an image, first we take all the data, training images and test images of all the shoes, and we build a GIST representation of all of those. And this is the pipeline of our method. What we do first is, given an image, test image, we build the top 100 to 200 visually similar images, and use that to train our SVM model. Instead of training one SVM model for per attribute, we train only the top 100 or 200 because we don't want to use those data in our training set which are not visually similar to our test image. Once we have the trained model, we use that trained model to take the test image and label it. Now, in a brief example, I would like to say I would like to show how does it help in online shopping. Now, imagine you just have 2 attributes. One is open, one is level of heels. Now, given a pair of sandals, you could say, if the user says, I like this pair of sandals, and I wish they were a bit more open, they would say similar level of heel, but more openness. She would get a refined set of results which have the same degree of heel, but they're more open. In the second case, she would say, I like the same level of heels and same level of openness, but different design. She would get another refined set of results as shown in the figure, in the image. Now, these are results. In course data set, we were getting about, on average, 86 to 87% accuracy. On fine-grained recognition, which is like 2 very visually similar shoes, but very subtle differences, we were getting about 61% accuracy. Now, online shopping is a big market. In the year 2013 itself, in US alone, they generated about $440 billion industry. Now, I think it's time for the online websites to come up and make online shopping a bit more smarter and friendly, so that which caters to very specific needs of the user. Thank you.
Fantastic. Well done.